This is Dennis Sullivan, 9Motion. What we're going to do is demonstrate a size 8 hybrid servo actuator. And I'm going to just breeze through the setups and the motions so that we just get a flavor for how things are set up. So first I'm selecting the PST8. That's this bottom actuator in the bottom right in the picture. You can see a size 8 motor attached to it, bearing housing with a tooling plate. Now let's go into setup and look at setup real quick. And you can see I've got a half amp nominal current and a 1 amp peak, 200 steps per. I've got a 360 line encoder. Now this is datasheet values, so that's if I want to detect a number of lines, I can click that and it'll drive it. If I've lost a datasheet, I can find out exactly how many lines that encoder has. Now I'm in the drive setup and I've got a current controller. Let's take a look at the current controller and see how it responds. It looks like I need to establish communication first, so let's just go detect. Now since this is a live demo, we're making the usual mistakes. I've got to establish communication before I go into setup. So let's go into that, let's detect the voltage. What voltage supply do I have here? That's going to take a look at that voltage and report it at 22 volts. I'm going to close it and say yes, I want to keep that value. Now let's look at that current controller. So I'm going to give it a look at a test current of a half amp, a quarter amp, and I want to test. I'm going to give it a voltage reference. And I'm going to see how quickly it comes up to a quarter amp. So it's running the test, and you can see what's going on here is the lighter colored curve is the reference, and it comes up immediately. And then at the actual motor current that we're looking at comes up in about a millisecond and a half. So you got an instant current rise for the voltage reference, and then you have the current, how that motor current responds to that reference, and it comes right up nicely up to quarter amp in about 1.5 milliseconds, and that's about what we want. So let's click OK. Let's look at the position controller. I'm going to make quick 3mm moves. I'm going to cycle them back and forth, and with that I'm going to capture a single stroke and display it so I can get a feel for how this motor is tuned. Now it's running this test right now. It's just setting up, and you can see that the motor is moving back and forth 3mm. I'm going to stop it. And it captures the last stroke, and you can see it comes in very nicely. It's a very, very good curve. You've got accelerator. The motor current is in green. The load position is in a reddish color, and you can see that the motor current comes up. The current is on the right-hand scale. That's up to half amp, and then it levels off. It rings just a little bit, a couple milliseconds, and then it comes across nicely. On top, you can see that it tracks right along. The encoder tracks right along with the command, with the position, the target position. And at the end of the move, you can see that at the end of the move, it servos right in and is dead nuts. Okay. So I'm going to click OK. That's tuned about as good as it can get. I'm going to click OK here. I'm going to download the setup table. That's the motor setup table. After I download the setup table, I'm going to come in and download the program. But before I download the program, I want you to look at the motion program real quick. Where do I get this peak current? First, I've got a tool inside of Easy Motion Studio. If I click on the torque on the motion external, I click on torque and I set an initial value of 1 amp. Remember, that's my peak current. It's going to tell me how many DSP counts there are for 1 amp. So that's 9,018. Now, this is not straightforward, but I'll just explain it. I've set the peak current actually at the RMS. That has a function of the motor. Different motors respond differently. This is a small motor, very sensitive, so I'm going to keep it right around the RMS current of the motor for this test program, this demo. I've set that around 4,500, or half the peak current. I'm going to click OK, and just remember that. I'm going to also show you down where the program operates. You've got a main loop, and in this main loop it calls detect jam. That's a call, and that's a function call out to here. And you can see that the JamDetect program, it's going to look out there, and it's going to look at in the night AP code I set up a percentage of peak current, and based on that percentage, if you hit that percentage or higher, it's going to trip the detect jam. Back to the motion program. I have the main loop. The next item on the main loop is the home. Well, if you've set, normally if you're not calling for home by calling a LabVIEW via your LabVIEw program or your communications program, you're calling one home. If you ask for a home, it's gonna set a home variable, and that's what this guy looks at. Go to home if it trips, and the home function is home and a hard stop, and here it is. Here's the home and a hard stop. Now in home and a hard stop, I'm actually going to set the reference. I'm going to set that home torque limit around 53, 58. And this is just trial and error. I get it perfect. Okay, so there it is. There's your current setups. Home and a hard stop current setup, and a JamDetect, on-the-fly JamDetect setups. So let's download the setup. Probably already done this already, but not going to hurt anything to do it again. And we're downloading the program now. That flashes it. After this is through downloading, it's succeeded now. I'm going to power down and power up, clear the registers, power down, and power back up. And then I'm going to come back into a terminal program, in this case CoolTerm, communications program. I'm going to click connect. I'm going to give it 9 carriage returns. I get night AP ready. So you can see that on the bottom right on that PST8, I've got it all the way out. I want to just do a one home 3. You can see it comes down, it drives all the way into the plate, stops at that hard stop, and then comes back off 1.5 millimeters. Let's take a look at that. Why did it do that? One print, and right at the top I got all my variables printed out. It looks like I have that set at 1.5 amps. Yeah, so the third axis is set at 1 point. So the home offset is 1.5 amps away from the hard stop. But if I do a one print POS, I'm at looks like I'm off slightly. Well, let's correct this now. Let's do a one set home 3 and set that up for 2 millimeters. One save. One rel 3, 20. Move it away. Let's move it back in. One home 3. Okay. One print POS. Good. We're squared away. Generally, the first time you do the first time you actuate the home, it'll be slightly off. You can see I'm off by 16.7 microns. Just ignore that. It's actually 0. And you can see on subsequent tries, you're going to be at 0. You're going to have 0. And let's take a look at the error. One print pause error, and we've got 0 error at that point. So this is X, Y, and Z error, so I've got no error. So let's take a look at JamDetect. So let's move 3, absolute 40 millimeters. I'm going to put my hand around the actuator and grab it so that I just a slight amount of force, and I just a little bit of force, maybe a half a pound, and it executed JamDetect, and it saw that current rise, and it reports back failed ZJam. So let's take a look at this. One print POS. It looks like we're at 4.8139 millimeters. And let's try that again. Move 3 to 40. Let's try that again. This time I'm going to let it go a little bit further. Jam it further. There it is. So I just jammed it again. Just a random location. One print POS. It got all the way out to 18.78 millimeters. So now what I'm going to do is move 3 all the way to 40. Yeah, I made it all the way because I didn't jam it. Let's do one print pause error. Yeah, let's just do one print pause. So there it is. It made it to 40 millimeters. One print pause error, and I've done it with 0 error, so I haven't lost anything. I haven't lost any error at all. So it's just to show you what that looks like, just to verify. Let's do one print pause error again. This time I'm going to put a little force on the actuator. I'm going to move it off just by putting a couple pounds of force. And just a little bit of force here, squeezing it together. I picked up 33 counts of error. But since I've let go, what's happened since we're in servo mode? One print pause error. It's back to 0. Well, because it moved back. I can move it. It's going to come right back to position. Okay, so there we are. Home 3 again, and you can see we're in business. So how's that feel? Let's do the ultimate test. One rel 3 40, and one move 3 back to 0, and I'm going to sacrifice my pinky. Ouch! There it is. Failed ZJam. Now I gotta get my hand out of there, my finger out of there. Didn't hurt at all. And there it is. Let's see how thick my finger is. One print POS. Well, my finger is exactly 12.422 millimeters thick. End of test. Thank you very much.